The content in this presentation aligns with pages 75 through 80 of your textbook, and it's meant to help you achieve learning objective number 12, which is to calculate 5 commonly used types of temperature data and interpret a map that depicts temperature using isotherms. Now, the last part we've already started working on in lab, and we'll continue working on that as the course progresses. But the calculations are things we'll be working on this week in lab. So it's a good idea to be familiar with these 5 different types of data for this week's lab. So if you haven't already done it, go ahead and skim through pages 75 through 80 before you watch the video, and pay particular attention to the bold words, which should include the key terms listed here. But also look at the figures and their captions. So please plan to read the content more thoroughly before you attempt the online quizzes. There are 5 commonly used types of temperature data used to describe the weather and climate conditions at every weather station: the daily mean temperature and temperature range, the monthly mean temperature, and the annual mean temperature and temperature range. The daily data is used to generate the monthly data, and the monthly data is used to generate the annual data. So the chart here shows the monthly mean temperatures for the Snohomish County Airport through 2000 for the year 2015, as well as the annual mean temperature, which is represented by the dashed line. And you can see that we reach our peak temperature in the month of July and see our minimum in December. And that should seem familiar to you. The middle bar, that annual maximum, should look a little bit low. I don't think July temperatures are 67 degrees. That's because it's the average or the mean temperature. And similarly in December, we know this December we were down into the 20s, but this number 41 was the monthly average. In a minute, I'll ask you to pause the video and try crunching these numbers yourself to be sure that I didn't make a mistake. Everyone makes mistakes, so don't feel bad if that happens to you. First, I want everybody to try to calculate the daily mean temperature using method number 1 that's shown here. This simply involves adding all 31 hourly temperature readings together and dividing by the total number of hours in a day, which is 24. Okay, pause the video now and do that math. Okay, I got 776.4 for the sum of all 24 hourly observations. And then I divided that sum by 24 hours to get 32.35 degrees. Is that something like what you got? The first thing I do to check my work is to rescan the list of data to be sure that my answer seems reasonable. I see that most of the numbers are in the high 20s to mid 30s. So I'm just kind of looking up and down this column of data. And 32.35, which was my exact total, falls about, right in the middle of those values. And that tells me that I'm not far off, even if I am incorrect. The second thing I will want to do is probably drop the numbers after the decimal points. Let me erase some of this, so that I don't mislead people about how precise my answer is. I'll round these numbers down to a nice simple 32 degrees, okay? One reason I do this is because I'm not positive that the absolute temperature minimum occurred at exactly 5:53 in the morning, nor am I sure that the daily high temperature occurred at exactly 12:53. It may be that we reached a low of 25 sometime before or after the 5:53 reading, right? In fact, what are the odds that the daily low temperature coincided precisely with our sampling time? I'm fairly certain that it didn't. The same can be said about the daily high temperature. I am confident that when I say that the lowest temperature observations occurred a little before 6 a.m. and the highest one occurred a little after noon. While we're on the subject of daily maximums and minimums, let's use those data to compute the daily mean temperature using a second method, which is also widely accepted. This one's a lot easier to compute because we only have to add two temperatures together. I'll tell you to pause again in a minute while you plug the daily high temperature in for Tmax in method 2 and the daily low temperature in for Tmin. Also, don't forget to divide by 2 because we're deriving this mean temperature from only two values. Okay, pause the video now and do that math. I got a daily mean temperature of 31.55 degrees, which rounds up nicely to 32. Does it bother you that we calculated two different numbers for the daily mean temperature? I'm looking at the exact values here. Should it bother you? Are you getting the idea that this isn't as precise as, say, brain surgery? And it looks like our numbers match up pretty well with official numbers found on Weather Underground. So here is the output on the Snohomish County Airport weather page on Wonderground, and they say that the mean temperature is 32 degrees. So one of the things about that rounding is that it sort of smooths away some of the perceived error you might have. So it's not that statistics is lying, it's just that the goal is to make a prediction, and sometimes those predictions have error built to the methodology. Okay, one more little thing about mean temperature and then we'll move on. What would happen to our estimates if the citizens of Mukilteo were lucky enough to experience localized clearing during the morning hours and the temperatures looked more like this? We would still have the very same daily mean if we calculated the temperature using method 2, but method 1 says it was 2 degrees warmer. So which one of those is right? Clearly the one that uses all the data is going to be a little bit more accurate, but what will the data mean? So what we're really doing is trying to get a number that we could compare with, say, the city of Spokane. We're not necessarily trying to replicate the exact way that the air temperature felt on your skin on this day. Okay, that wasn't hard math, right? The hardest part was adding 31 numbers together. We'll calculate the daily temperature range, and it won't be much tougher. In fact, it's probably even a little bit easier. So we just scan the list of data and find the highest value and the lowest value in the list. I'll give you a minute or two. No tricks here, just the largest and the smallest values. Which ones could they be? Yeah, the circled ones, right? So subtract the maximum or the minimum from the maximum, and what do we have? We have 11 degrees Fahrenheit. Okay. So rounding to the nearest degree, we're at a nice even 11. The third commonly used type of temperature data is the monthly mean temperature, which is calculated exactly the same way as the daily mean, except we actually use the daily mean temperatures to determine our average instead of the hourly mean. So that means we need a daily mean temperature for each day of the month before we can calculate the true monthly mean. So we have to wait until the month is over. Adding up the daily mean temperature for every day in December 2015, we get a total of 1272, and we divide that number by the number of total data points, which is the number of days in the month of December. Finally, rounding to the nearest degree, I get 41 degrees after rounding. And so did the people at Weather Underground. So we're still in good shape. The last two commonly used types of temperature data are the annual mean temperature, which is determined by adding the 12 monthly mean temperatures and dividing by 12, the number of months in a year. And the annual temperature range, which is determined by subtracting the lowest monthly mean temperature from the highest monthly mean temperature for the Snohomish County Airport in the last year. That average comes to 53 degrees Fahrenheit. And the annual temperature range was 67 to 41 degrees. Okay? So total range of 26 degrees Fahrenheit. So you can imagine that comparing two places, comparing this to Spokane on the east side of the mountains, they're going to have higher highs in the summer months and lower lows in the winter months. So their range is going to be much greater, even if the averages come out to be about the same. And I don't really know if that's true. But when we look here at two sample cities, and this is a cautionary note, don't assign too much reality value to the average temperature data. Keep in mind that the range of temperatures is really an important number too. These two cities, San Francisco, California, and Richmond, Virginia, have the same average temperature and are even at the same latitude. But Richmond has much higher summer temperatures and much lower winter temperatures than San Francisco. Why do you suppose that might be the case? We know that they're both at the same latitude. One's on one coast and the other's on the other coast. Well, we'll talk about this more in the presentation about temperature controls. So use the content in this in the Canvas site and as well as the outside internet sources if you'd like to find some of those to verify that you can answer these questions before the midterm exam. If you can comfortably answer these questions, you are in great shape for the test. If you can't, review the textbook, rewatch the video, and see if your abilities improve. If you're still completely stumped, remember to start a discussion on the Canvas site or ask me for help.